Okay, so we're going to temper metals in different ways. We're going to heat them all up, and how they cool is really the key to tempering. So let me grab a quench thing first. We have two different samples that we're going to work with. We have a high iron content, that's going to be, or high carbon content rather, that's going to be our steel berets, hair clips, and then the low carbon content, which is going to be our staple, or not our staples, our paper clips. So what we'll do is we'll heat each one of them up, and we're going to cool them in three different ways. First way, we're going to just let it cool. The second way, we're going to quench it and have it cool very, very quickly. And the third way, we're going to quench it, then heat it up a little bit, and then let it go. Okay, so hold on. Okay, here we go. So we're going to use a butane torch. This is going to burn at approximately 2,000 degrees Celsius. We want it that hot in order to get the molecules within the iron and the steel, really, in order to get them kind of moving around and changing possibly their crystal pattern. So the crystal lattice that we're looking at for a cooled steel is a BCC, so body-centered cubic. When it heats up, it'll change to a face-centered cubic, and then what happens after that depends on how it cools. So we've got it red hot, and the first sample, we're just going to let it cool down. Second one, we're going to quench after we get it red hot. This one we're going to get red hot, quench, and then heat it up again and let it cool. But I'm going to use a match so it's not as hot. So it's warmed up at approximately 450 degrees Celsius. And it quenches nicely. Same thing for the staple, I keep calling them staples, they're paper clips. I'm interested in, if I can open one up, I'm interested in this bend here. That's the bend that I want to heat up. Okay, so this one I'm just going to let cool. And I'm quenching. Heat this up, quench. Heat it up to about 450 degrees. Quench. Okay. So now they're all heated and cooled, and the experiment is going to be to see how they differ when we unbend them. So this first hair clip, I'm going to unbend it. Shows a little bit of resistance, but not really. It pretty much just opens up for you. Okay. The second one, this is the one we quenched. I'm going to open it, and it doesn't even open. It's so brittle it breaks right away. Notice that it didn't bend. It didn't bend at all. It broke right there. I don't know if you guys can see that. I'll do a video over of all these after they're done. Now this is the one that we tempered. So we raised it to 2,000 degrees. We quenched it. We raised it to 450 degrees, and then we quenched it again. Okay, so this one broke, and it really didn't, the middle part really didn't deform all that much. So it was able to withstand some force, and it became brittle there at the end. Okay, let's look at our paper clips. So I called them paper clips this time, I didn't call them staples. So this one unfolded just like you would expect any paperclip to. This is the one we quenched. Okay, so the quenched one doesn't really deform that well. It's holding its shape more or less here in the middle. This one has been tempered, and it fully deforms. No, okay, so that may not have been what we intended, but it still held shape sort of in the middle. So that is this experiment. Now your job is to figure out which one of your samples matches which one of the samples that we have here.